right, let's do some more examples on expected value in 11.8. We just did one about insurance premiums. We did one on the SATs. Now let's talk about games of chance, gambling, right? And so we're going to calculate expected value when you play a game over and over and over again. We're going to calculate what's expected to happen. Are you expected to win, positive? Are you expected to lose, negative? And on average, about how much per game? We're going to calculate that expected value by multiplying the gains or losses for each possible outcome by its probability and then adding them together, kind of like how we did in the other examples. And so what I like to do on all of these is I like to make a chart, kind of like they did in the SAT example, where we have our different outcomes, where we have what we gain or lose depending on the outcome, and then the probability in our third column. And that way we can easily organize ourselves with the three different things we need. We can multiply them, and then we can add them together. Okay, so let's do that on example number 5 and 6. So on example number 5, it says a game is played using one die. If the die is rolled and shows a 1, 2, or 3, the player wins nothing. If the die shows a 4 or a 5, the player wins $3. If the die shows a 6, then the player wins $9. If there is a charge of $1 to play the game, what's the game's expected value? Describe what this means in practical terms. So what happens, what does it mean when you get an answer? And so again, I suggest that you organize yourself on these different types of examples. I've done it for you on the notes, but I don't know if my math lab's going to do it for you on the homework. So this might be a good habit that you get into as you're doing your homework and your test so that you can keep yourself organized. Make a chart of the different outcomes. Make a chart for the gains and losses depending on the outcome, and then the probability. So here we go. What are the different outcomes when we go to play this game? We go to play this game and we roll the die. What could possibly happen? Well, one of the options is we can roll a 1, a 2, or a 3, right? Well, what's another option? Besides rolling a 1, 2, or 3, couldn't I also roll a 4 or a 5? And my last option is I roll a 6. So I've listed all my different outcomes, a 1, 2, or 3, 4, 5, and then a 6. Now let's go through and figure out what we would gain or lose depending on that outcome. So if I were to roll this die and I roll a 1, 2, or a 3, do we win or lose, and how much? Now be careful. It says in the problem that the player wins nothing. But didn't you have to pay $1 to play? So aren't you actually down $1 if you roll a 1, 2, or a 3? You didn't win anything, but you paid $1 to play, so I'm still -1 in my pocket. So make sure that you symbolize that with a negative sign. That means something very different than a positive one. All right, let's do the same thing for a 4 or a 5. If I roll the dice and I land on a 4 or 5, what do I gain or lose? Well, it says in the problem that the player wins $3. But now be careful. When we win $3, haven't we actually paid some money to play? We've paid $1 to play. So really, I'm not up $3. I'm really only up $2. Think about it. I give you $1 to play this game. I'm down $1. When I win 3, I'm really only up $2 because I had to pay $1 to play. Do the same thing when you roll a 6. If you roll a 6, it says you win $9, but how much are you really up or down? You should really only be a +8 because you had to pay that $1 to play. So that's really key here, being careful to think about what's happening with your gains and losses. Now I want you to go through and figure out the probability of each of these outcomes. What's the probability that you're going to roll a 1 or a 2 or a 3? What's the probability that you're going to roll a 4 or a 5? And what's the probability that you're going to roll a 6? The probability that you're going to roll a 1, 2, or 3 is 3 out of 6. The probability that you'll roll a 4 or 5 is 2 out of 6. And the probability that you'll roll and land on a 6 is 1 out of 6. Now that we have the gains and the probability, let's go ahead and multiply those together so that we can add them. When I multiply those together, I get -3, 6. I get 4, 6. I get 8, 6. And since they all have common denominators, now I can add them together. I ended up getting 9/6. Did you? It doesn't really mean much though, so let's go ahead and divide that into a decimal, and then let's explore what that number actually means. I ended up getting 1.5. So what this is really saying is if you play this dice game over and over and over and over, because it's a positive 1.5, that actually means I'm going to win on average $1.50 per game. I'm not always going to win that every single game, but if I play this game over and over and over, the chances, what's going to happen, expected in the long run, is I'm actually going to win $1.50 per game. Pretty good game. I'll probably keep playing. Let's look at this next one. Example number 6 says to find the expected value of betting $1 on the number 20 in roulette. Remember that roulette wheel we talked about before has reds, blacks, 1 through 36, 0, and 00, right? It says if the ball lands on that number, you're awarded $35 and you get to keep the dollar that you paid to play. If the ball lands on any of the other 37 slots, you're awarded nothing and the dollar that you bet is collected. Let's figure out the expected value. What's expected to happen if you play this roulette game over and over and over again in the long run? Okay, so let's organize ourselves with the chart. We have our different outcomes, we have our gains and losses, and then we have our probability. So let's think about our different outcomes. When we go to play this roulette game, what are our different outcomes that could happen? Well, we could land on the 20. Woohoo, that's what we wanted, right? Or we can land on any of the other numbers, right? Those are only two options. I'm either going to land on the winning number, the 20, or I'm going to land on another number. So what happens, what's my gain or loss when I land on the 20? Remember, we paid $1 to play. But when we land on the 20, don't we get that dollar back? So now we're at 0. And then we get $35. So aren't we up $35 if we land on the 20? Okay. What happens then if we land on any of the other slots? We're down $1, right? Because didn't we have to pay $1 to play? Okay, so now that we have the gains and losses, let's figure out the probability of each of these different outcomes. So what's the probability that I'm going to land on the 20? Well, isn't it 1 out of, I don't know what happened with my 1. 1 out of 38. There's only one spot that's numbered the number 20. Out of 38 spots, my probability is 1 out of 38. What's the probability that I'll land on any of the other numbers? Well, there's 37 other slots out of 38, so 37 out of 38. Now that I have my gains and losses and the probability, we're going to multiply them together. We're going to add them, and I'm going to divide so I can figure out my expected value. Uh-oh, did you get a negative on this one? What do you think that negative means? Yeah, it means if I play this roulette game in the long run, on average, I'm expected to lose 5 cents per game, right? And that's how they make money in Vegas. 5 cents doesn't sound like a lot, but there's a lot of people there betting a lot of money, losing a lot of money, because that's what's expected to happen in the long run. You're expected to lose, on this example, 5 cents per game. Okay? Make sure you practice your expected value. Like I said, make sure that you stay organized. I suggest you write your little chart with your outcomes, your gains and losses, and your probability to keep you organized. This was our last section in Chapter 11, but I know we covered a ton of stuff. Getting a little more difficult in 11.5. So I've put another 11.5 practice worksheet on Canvas. I highly suggest you do that worksheet. There's an answer key to check your answers as soon as you're done with that. And I really, really, really do think that everybody needs to make sure that they do the Chapter 11 review multiple times. Do it once, do it again if you need to. Make sure you're not just getting the green check mark, but that you're truly understanding each question. So you can do it as many times as you need to. 1, it's going to help you review for your test, but 2, remember, it's going to give you that extra credit for just doing it, okay? Lots of stuff that we covered in this chapter. Make sure you're doing your homework, you're practicing, and that you're asking questions if you need it. I'm here if you need anything. Just let me know, okay?